Yo, Philip.
Hi, Alex. Tommy.
Yo, Tommy.
Gate
How
master.
goes? Good. I see that nod. I'll take that. Kevin, nice to see you.
Yeah, everyone.
Hi.
What's up, Kevin?
Long time. James, nice to see you.
Hi, James.
I hear we have some benchmarking stuff, James, which is cool.
Hi, hello.
Yo.
Uh, so did I miss something? What were you saying?
Oh,
Could
I
you please?
thought you were working on some benchmarking stuff. Maybe it was a different James.
Yeah, yeah. We were working on some sort of benchmarking on that. So yeah, particularly we are still stuck on the white paper
Yeah,
side of thing, and over the yeah, we are waiting for the infra from CNCF something.
yeah. I'm excited to hear what you got cooking. Um, Nice to see you, Marlo. Made it back. We'll have a couple more minutes of just easing people into the post KubeCon batch meeting. It's always a little shaking off the rust. I was doing things yesterday. I was clodding it up, making batch better for you and me. Yeah. I'll see what I can talk about yet. It's all like incredibly uninspiring, except it's exciting for me. I'm like, yes, we finally have a place in GitHub that we can put files. This is major achievement. That's me. Yeah. So nice to see you, Victor. Doom. Wait one, maybe 2 more minutes. There'll be other people joining surely. I actually advertised this one. Boom.
On the other meeting, I saw Kevin there as well.
Hello, Kevin.
Yeah. Hey, Kevin. Boom. Um, Marlo, what we got in terms of updates? I've got some updates in terms of just like the housekeeping stuff that I was desperately working on yesterday. I so desperately want to tell everyone that I did things. It's mainly the thing, but we've got some benchmarking stuff. We've got some white paper stuff, maybe. I don't know whether you've heard any white paper stuff.
I'm still waiting on approval from the talk, so I need to go follow up on that because we just keep waiting. But the paper's done, just waiting for approvals. And then where to publish is the next question, which maybe it's our fancy new repo.
Yeah, yeah. Well, maybe I can start chatting about that briefly. We have a spot. It took some months, um, but in here. This is the TOC. They tried last year to, or they have moved all the documentation that once existed into here. We're now under tags, tag workloads foundation, and then we have the subprojects batch page. And so we can put all sorts of things in here now. And part of what I was doing was to fix it up. So there's a PR here that should change a bunch of stuff. I think this is mine. Is this 2009? Yeah. This is mine. And then I also was trying to move the landscape that we once published. Medi had published it for us, this thing. Boom, boom, boom. This is the old documentation, and so I'm trying to move this thing over into our new universe, which is here. So we could potentially take the white papers, create a PR, make a directory called white papers, and shove those white papers in the directory called white papers. We finally have a place of our own, kinda. It's approved by other people, of course, but like, what can you do? White papers, they can't object to white papers, can they? So we'll chuck them here. There's some other things we could put here. One of the other things that I was trying to do was, oh yeah, this is me. It's terrible. Don't look. But there's this page of videos. This meeting will get put up here, and you know, there's sort of a running log of the stuff that we do. I've been trying to figure out a good way of updating our vaunted notes documentation, wherever that is. Boom, boom, boom. This one. Oh. This, as Kevin pointed out yesterday, has not been updated since January. Thank you, Kevin. Appreciate the reminder. But this is always fairly miserable for me to update by hand. Been trying to look for a way to either update this, or the other option is to start making a meeting notes directory in here, and like have a summary readme of all the meetings that we've had, maybe that looks something like this meeting notes page, but with a lot of the things like the audio transcript and chat saved into some directories, and you know, make it nice, make it searchable, make it sort of available on GitHub. Curious, like Kevin, you were looking for this page the other day. Seems like it might actually be useful to keep this page around. It'd be simple enough to automate this page as well, but you know.
Yeah, I mean, a habit I always have is to check the agenda to see if something is of interest to me. So I assume that's what I usually do for most of my calls.
Cool. Well then, yeah, as I say, it's not super hard to also update this if I'm accomplishing automation stuff. So yeah, this page can live on. Anyway, that's the kind of shit that I've been doing the last couple of days, because as you can see, it's not reliable to rely on me to manually update shit. So looking for a better way. That's the sort of house cleaning stuff. White papers, my stuff, benchmarking. Is there any useful update there, Philip, James? Anything to say?
Oh, well, now that James will give more information, as he created the draft for the paper. But right now that the conferences are done, we are ramping up. And also there is info that James got accepted to CERN. So just want to say kudos. So yeah, over the summer, he'll give more info, of course. Wanted to say that in the next months, we will focus on benchmarking at the higher pace because of that. So right now we are speeding up.
At the higher pace because he will be in the accelerator tunnel being accelerated? Is that the, yeah?
Yes,
awesome.
Exactly.
Good luck, James. Oh, I think you might be muted. Oh, sorry, we can't hear you. No. You're clearly already moving so fast. Audio, like sound waves, are escaping your microphone. Huh. It's now muted. No, I can't hear you. Is it the wrong audio device? No. But this has us tantalized. Oh no. Well, yeah. All right. We'll give you a minute. Marlo, was there anything else? Um, anything from KubeCon worth mentioning?
Um, I found Nikki, who was part of the Green Review, so I've asked her to go and talk to Philip and uh, James on benchmarking and get us there. I don't have any answers yet on where the clusters live, so I have some questions out, but I need to go find someone to wrangle them, but I don't know who the person is. Um, I don't know. We had good attendance for the Slurm Bridge batch talk. The Workloads Foundation talk was good. We had reasonable attendance there. Um,
But nothing like this. This group should all go check out or something like that.
um, no, not really. I mean, we have the paper we just put through, and there's other papers we could start work on if we want. This benchmarking stuff is important because there's lots of schedulers trying to figure out how good they are, but we can't do that without a workload. And then we can't, because we need a workload to test the scheduler to queue up and then see how quickly we can crunch through actual workloads. It's beyond just the scheduling.
Mm-hmm.
Um, yeah.
Well, maybe. Hello, Vivian. Nice to see you. Maybe we can come back to the benchmark topics later. Jump into the workloads API stuff that Kevin has so kindly joined us to talk about. Hello, Kevin.
Yeah, so I'm just going to share some slides that I gave at the last part of my talk at Working Group Batch. I talked about this stuff, so I was just going to go ahead and share those slides and then kind of walk through at least what we've been up to in the Kubernetes group. I'm going to go ahead and share my screen. Can you all see my screen? Actually, I assume.
Yes.
Do you see
Yep.
some slides? Okay,
Yep.
perfect. All right. So yeah, okay. So in 1.35, the Kubernetes community has decided to finally bring gang scheduling in tree. There was a good amount of work done in 1.35, but unfortunately, there were a lot of changes we had to make. So I kind of just think if you are using the workload API 1.35, there will be some changes, unfortunately, but I'm going to just talk about kind of the features that we did in 1.36. So basically, one of the things we were finding with gang scheduling is I think a lot of people will oversimplify it to just say it's all or nothing. And when we are in the discussions with different workloads, what we're finding is that there's almost always a caveat. You have usually that there are scheduling semantics per each group of pods, at least especially in Kubernetes that we see. And for job set, like we might have a leader and a worker, and in some cases, like the leader the leader and the worker have to be scheduled together, but then the worker can be you can be more fungible. You can trim some of your workers, especially in Elastic cases. And so we're finding that it's actually quite challenging to do gang scheduling if you just assume everything's all or nothing. And I'll talk about that more. And so we been talking about different workloads, and generally, I'm gonna highlight three separate kinds. Job is mostly simple. A lot of people want all the pods in a job to be gang scheduled. There's also a caveat there where some people would like the certain indexes to be getting scheduled slightly differently, but we haven't really designed that one yet. This is more coming up with a lot of index jobs, and like the index 0 is a leader while the other indexes are workers. So there's some semantics there, but we haven't really seen a strong use case for that one yet. So for job, it's mostly all or nothing. Job set, we find that there is a bunch of variations. The most common is a leader and a worker. So I guess I have two cats represented as pods, but usually a leader is one pod, and you have a bunch of workers. Usually they're scheduled together, but as though the workers can be, if the leader fails, the entire job has to go away, or has to be trimmed. But basically, this is one example. Kubeflow has a bunch of others where they have we have kind of an execution policy for pulling models, pulling data sets, and then running training, and then that kind of orchestrates how we want the gang scheduling. Usually, the training part is all kind of scheduled together, but then the initializer and the data set pulling jobs kind of need to run one after another. So that kind of changes like how you represent gang scheduling at the job set level, and then a big area that is coming up more and more is an area called disaggregated serving. From my understanding, it's kind of this idea of you have pre-fills for the, I guess, input data for tokens, and then the decoders are your output data, and usually these have different requirements. This is coming from the kind of LLMD and the Dynamo communities, or really any kind of one doing multi-node serving. But generally what we're finding is there has been a lack of an API around this one. So a lot of people are still kind of figuring out what's the semantics for gang scheduling. And this kind of influences a lot of our design going forward, because we're finding that there is some need for a newer pod group representation. Like I'll talk about later how we have two new APIs, workload and pod group, for disaggregated serving. There are some ideas of having a nested layer for pod groups to represent some more of these complicated APIs, but that's future work. But generally, it's kind of complicated. And then the other thing that I think a lot of the gang scheduling solutions in the core co-scheduling, we're always focused on, I have a pod group and then I schedule together, but things like preemption usually aren't handled that well. And in this case, it's more like a preemption is, pods getting terminated because someone's telling you to do it, and you kind of want the termination to be all or nothing, or at least control how much you're willing to tolerate disruption. A lot of times AI workloads are kind of fickle beasts. So most people, usually when one pod goes down, a lot of frameworks do not really handle that well. So a lot of times it's usually better to just kind of terminate everything. But there are cases where some people want the ability to partially preempt a workload, but keep the rest of it running if their framework is smart enough to handle that. So that's like another use case that's been kind of coming up. So generally, what is workload aware scheduling? At a high level, the idea is we're trying to move beyond pod scheduling. So you're familiar in Kubernetes, you have a pod, it assigns a node, and usually a workload kind of wraps a bunch of those, but the scheduling is kind of it's probably done in parallel, but it's still trying to assign individual pods to a node. We want to kind of change that going forward, and that's why we have a thing called workload aware scheduling. At a high level, it is really just two APIs right now. You have a workload API, which is a static definition, and you can specify how much pods are considered to be a gang. And then since the workload is static, it's more of like a policy. There is no status field on it, and it's more like a definition that controllers can read to create something called a pod group, which is kind of our runtime. This is the one thing we changed in 1.36, because pod groups we found for functionality like DRA and topology aware scheduling we know that this becomes more runtime dependent, especially DRA, where you may want resource claims being being tied to the life cycle of a pod. So, you can imagine the allocation of a device is represented by the runtime of the pods. And if your pods terminate, you want to deallocate and create a new claim. That's kind of one of the goals we have with the pod group. So this is, runtime specifies, a number of pods that are considered in your gang. And then it has a status to kind of represent scheduling decisions and other stuff. So basically, yeah, the workload aware scheduling, I wanted to highlight the API so you can see from a workload. You have a definition of a pod group template, how much the min count as part of your gang scheduling policy. And then you have a pod group, which kind of references the workload. And then at the pod level, you can add a field called a scheduling group, and then a pod group name. And this kind of tells a pod that you are part of a group. And this tells the scheduler to kind of schedule the group as a whole. And what I'm showing here is not really the end state we want. This is kind of what we are calling, bring your own workload or bring your own pod group in case the controllers themselves are not handling this for you. The idea is that you can always create a workload in a pod group, and then the controller can create, you can add that information to the pod template so that you communicate to the scheduler that you want gang scheduling, but you're responsible for the life cycle management of both the workload and the pod group. What my vision as like a working group batch person in the Kubernetes area is to try and hide the details of workload and pod groups and push them onto the controller, because what we find is that the controllers know a lot more about life cycle. They know when I need pod groups to be deleted and new pod groups to be created. The controller can orchestrate and handle that life cycle rather than putting it on the user to kind of have to handle that. So yeah,
on the
go on.
If you go back to that,
Yeah, sorry.
the min count there. Does it always need to match up? Could you have two pod groups of 500 inside the workload of 1,000? Like, what's the relationship between workload, pod group, and job here?
Yeah, it's a good question. In 1.37, it's all, I think you could have like a workload can have multiple pod groups, and then you could always reference that. I don't know. That's kind of is very similar to what we've been talking about for like job set or like Kueue, where we may have a more elaborate definition where you have a workload, and then that workload can contain multiple pod groups. And then you can kind of like for a job, it's kind of not, job's not great because like for the most part, you are going to have one pod group right now because we don't have much ways to tune that. But for something like job set, you could imagine like a leader and a worker are separate pod groups and other stuff like that. That makes sense.
I mean, I guess another way of asking is like, if you set the scheduling policy at the workload level, do you need to set it at the pod group if the pod group is referring to the workload job one?
Yeah, so the idea, what we have is that the workload is more the static policy that the controllers would read, and then they create the pod groups from that. And then the controller is kind of is the life cycle of the pod group is controlled by the controller, but the workload kind of informs how the pod groups get created. Now,
I see. That's why it calls it a pod group template, and then it sort of like creates the pod group. Like it'll instantiate it with the same min count that's in the template. That's what
yeah, and there is a lot of interest in making the min count mutable. Right now, everything is immutable, which blocks a lot of cases of elasticity. But so there is in 1.37, we do know we need to make this mutable for, elastic index jobs and stuff like Kueue and leader worker set, where people do a lot more downscaling and upscaling. And I will show a demo, kind of all this together with the controller stuff
yeah.
at the end.
Cool.
So, sorry, baby's in the background. Workload aware disruption. This is basically we're allowing you to toggle whether or not pod groups can get preempted as a whole or not. The idea is that we can add more policies. So one of the things we want to talk about is, can you do partial preemption of workloads? So trimming some of your pod groups if you have kind of a tolerance for that. And some of this is over time, we want to add more functionality into preemption to allow for this. Another area that's kind of becoming more and more popular for large scale training or like anything really now is that DRA is you can share resource claims. And one of the big things for, I guess, the GB200 or Blackwell is that you have a concept of an IMEX channel where you can have multiple you can have the channel shared across nodes. And then what that means is that in some cases you want multiple pods to share the same resource claim. This was kind of blocked by what we had currently because you would have to kind of manually orchestrate all of this. And so one of the features we did get into in 1.36 is the ability to have a pod group resource claim. So all the pods in a group will share the same resource claim, and then ideally, since it's part of the workload and pod group, this can be kind of orchestrated by the controller so that the pod groups are, you want the resource claims to be life cycled with the pod. And that was a big reason why we had to move to the pod group as a separate runtime API. I took just an issue here from, I think this was a person that gave a call or talked with you all maybe a couple weeks ago, John, about kind of, this is a issue where they had a request for job set where, basically they want each job and all the pods to share the same claim. And this has kind of been long standing for us for a while because it's not trivial to actually implement this without the workload API and the pod group. Luckily, these requests have been coming up, and this has kind of motivated a lot of the reason why we need to, shift to workload aware is for more of the stuff that's coming from the devices communities. So the last thing I wanted to talk about was, our kind of goal for the workload aware controllers is like at a high level, it's relatively simple. And as I mentioned earlier, my goal as working group batch side is that I want to try and push this orchestration to the controllers and not put it on the community to kind of orchestrate this themselves. We found over time that doesn't really work that well. For job set is, the way we enable a distributed job is the job set orchestrates jobs in a headless service. And you could always done that before, but very few people did that, or they created their own CRD to represent that. And so we know that over time, gang scheduling if it's going to Kubernetes, we know the controllers need to handle that. So I highlight some work and designs going on in 3 different communities, but generally I mentioned, your controller should create the workload, and then the pod group is created from the workload pod group template. And typically you make sure the pod specs reference, I think it might be a typo here, the scheduling policy. And that's how you kind of get gang scheduling for your workloads. And so, sorry, is there a question?
I think it was clear. Sorry. Yeah.
No, it's all right. So yeah, and the one thing I did not talk about, mostly because in this talk I had a lot to go through, I did not talk about topology aware scheduling. That is another feature that was added in 1.36. But in 1.36 we had 5. I can't count. We had 5 features that went in alpha, and the new API from v1 alpha 1 to v1 alpha 2 in the workload and pod group. And I will give a demo of what I call gang jobs, which is how the job controller orchestrates this for us. And the big things that are going on, ideally once 1.36 is out, my hope is to find somebody, or if someone has volunteered, to take on the job set work to kind of like prove out how this would work with something like a higher level controller, like a job set. There is a separate effort going on in design for Kueue to kind of prove this one out. A big area that's on my radar / a lot of the folks working on Kueue is, now that the scheduler is handling stuff like, workload preemption and gang scheduling and other stuff, how does an external controller or a scheduler like Kueue will work with these constructs? If you're interested, I can happy to talk more about that one. There's a lot of stuff going on in SIG scheduling to kind of enable some of this. And there's a concept of, sorry, go on, Alex.
Yeah, I sort of was interested in something along those lines. Maybe it's a little different question, but Kueue already has a concept of a workload, right?
Yeah, unfortunately, it's unrelated, but yes, it does.
Yeah. Does that intersect at all? Is that complicating factors or like?
So what I was doing in 1.36, well, I have been playing around with how this would work. And so in 1.35, what we found is it broke our short names. So if you do kube control get workload on Kubernetes with these APIs installed, it would no longer find the Kueue workload. It would find the in-tree workload. So we had to do some renaming of at least the short names so that we know like we don't eventually conflict. Unfortunately, they are very different, and that's something we aren't I don't think we're gonna converge them because they're different constructs. Like the workload API in Kueue is more around like the quota management, and it's kind of the intermediate representation that Kueue uses to check for quota, which is not exactly what the scheduler would use. So I don't see those APIs going away, but there
Renaming
is,
them for clarity, like eek.
yeah. I mean, it's kind of not great. Like no one wants to rename. We can't rename the Kueue workload API now because it's V1 beta 1 or V1 beta 2, and we have a lot of production users. So, and also generally when I talk to the API folks in my org, it's usually not even, it's always recommended to use the full domain for APIs for this reason. Like you will find cases where if different CRDs use the same name, like the short name for an API, there's no guarantee you'll get the resolution correct from cluster to cluster. So typically we have started just trying to make sure to use the full name for these in our docs to make it clear what we're referring to.
And that's one half of it, like the machines understanding which thing they should be using. It's also just to explain this to the people who are using Kueue. It's like, okay, workload is this thing, but also workloads is this thing, and it's just
it's not great, and that's sort of, I think there was actually part of what we did at KubeCon was to make sure that Kueue and to give you some, like, a lot of this work is being done by Google in the Warsaw office, and those same people are also working on Kueue. So there is a lot of interest in making sure these overlap, and we actually made sure to have the workload aware scheduling people at our Kueue booth to kind of answer questions, because I think generally a lot of external schedulers in my eyes are in a little bit of a weird state now because we have gang scheduling in tree coming, and then a lot of schedulers handled gang scheduling separately. So I like a lot of people are wondering how to converge these concepts, and same for Kueue. And Kueue also, one of the major things that Kueue did have was topology aware scheduling, and what the goal is for SIG scheduling is to create some kind of scheduler simulator. I forgot what they're going to call it, to kind of reflect stuff like pod groups and workloads, so that Kueue can call this to kind of simulate whether or not you can place a workload rather than having Kueue kind of take on the scheduling aspect. Because I think everybody, like what Kueue has run into is, topology aware scheduling works for what they have, but we are still trying to get DRA added into topology aware scheduling, which is not yet supported. And that's even without this work. And so generally, I think there is a hope that Kueue can start leveraging the topology aware scheduling in tree rather than what Kueue has had currently. But this is like long term. And that's the same thing for auto scaling. Now that auto scaling has its own concept of workloads and pod groups, we know we need the kind of a scheduling interface for the autoscaler to auto scale workloads. And then the other feature that's still being designed is to kind of enable disaggregated serving or leader worker set, where you have kind of this concept of gang of gangs. The name is still up in the air. I know this is a big item that people want to try and solve, because leader worker set, they still have some issues with the API currently. So I think there will be some future work in 1.37 to solve this. And so I will just shift kind of to a quick little demo to kind of show. I realize I probably did not share this. Give me a sec. Okay. Can you all see my screen?
Yes.
Okay. So I'll just go ahead and create damn it. Sorry, we have an emission controller now. So you can see here in actually, let me show you what is enabled to do this. So I built, this is not yet released. We're very close. I don't know where we are in the 1.36 cycle, but we are dev complete. I think we're waiting for the release in the next couple weeks. So I built a kind cluster off of main and just kind of showed to show for demos. So right now we have, I'm gonna show our gang job, kind of our pilot, if you will, to kind of prove out that we can work with other controllers to kind of show that our API is at least solid enough for controllers to adopt it. And plus there's some stuff to figure out from the job side also. So you have 3 feature gates, gang scheduling, generic workloads, kind of like the API feature gate. And then we have the gang job stuff. And this is a dummy kind cluster. So I have an example of bring your own pod group where I created a workload that has 1,000 pods. This will not schedule because my kind cluster does not have the ability to do that. But I'm going to go ahead and now create a pod group, and I'm going to create the job template. So if you're familiar, most of you are familiar with Kubernetes, you'll know for this, since it's not able to schedule, you'll see that all 1,000 of the pods, they're still waiting to be created, but they're all kind of stuck in pending because there's not enough capacity on the cluster. So that's kind of what we are hoping to see with gang scheduling. And you can kind of see for the pod group, you can see on the status, it's pending, and kind of represents the policy in the gang, in the workload. And this is the object. So that's kind of the bring your own pod group case. That's what we kind of expect people can do if your controllers don't support this. The way you kind of do this is, you look at the job template. I have the scheduling group name. So this represents the pod group name. And so why I said this is fine. So this is a pod group name, and then that's kind of how you link stuff. So that's bring your own pod group. And then we have and then we have a gang job, this is the one, let me just show. So in this case, the requirements we have for job and gang scheduling are, it has to be an index job with parallelism more than 1. And that's kind of, this is what we're doing for our alpha run of this, just to kind of prove out the life cycling of all this. So when I create this, what you're going to see is, it's not that exciting, but under the hood, it's actually creating the workload and the pod group for you. And this is kind of, at least one of our goals for a lot of the controllers, is that they usually are the one that better understands how to handle stuff like scheduling or failures, which is, we know, very important for gangs. And yeah, that's kind of all I have. And that was, yeah.
Thank you. That's great. A good blast through the new APIs. Curious, a couple of thoughts we could talk about topology awareness some more. That was sort of a topic we brought up with Slurm. But I'm curious, any questions from the crowd after seeing all that? Does that affect how you think about workloads or the batch scheduling stuff that you do?
I think I'm going to replay the meeting after to get the kind of lead up context to that demo, just to see where the conversation was at.
Oh, you had to drop for a little bit, didn't you?
Yeah.
Yeah. I'm curious, Marlo, do you, is there any implications for you in Slurm and Slinky land here?
We just have to translate the job over, which we've already done. I have it in draft, which I'm waiting for them to merge, because when they merge, files change, and I'm lazy. I don't want to do it twice.
You're saying you have to translate the job over.
Yeah, so the way we're working on all of the different workload types is we're basically translating into a Slurm job, and then placement is chosen by the Slurm controller for bridge.
So
then
you were talking about a Slurm job, not the job underneath the pod group here.
Yes, I am.
Oh.
So it could be under the pod group. So if you're using Slurm Bridge as the backend, we already have workload aware scheduling implemented.
Yeah, okay. So you're saying you're translating the workloads into Slurm jobs? Or
yes.
You're talking about the jobs that are created
into a thing that Slurm can control. So with Slurm Bridge and with new Slurm, there's a thing called external nodes. So we don't have to work on a thing where Slurmd is running, but we do need to be able to pull in what resources are on that node, and then we schedule accordingly. We translate that into the Kubernetes workload, or at least we place it, we kind of hard place it on which node it's going to be on, and then we throw it back at Kubernetes and have the kubelet decide what resources are underneath.
Okay, I think I understand.
And if you're using DRA, we can do extended resources. We just did a bunch of new work. Anyways, the summary is we are using workload aware scheduling.
Awesome. Very cool.
All right, it'll come out in Maine as soon as this lands. Philippe has a question.
Thank you. Yeah, so I wanted to ask, since I'm thinking about the possibility of adding nodes and scaling our cluster when we get into the position when we have unschedulable job or a workload. So what would your proposal be right now with which tech stack to combine if we want to be able to add more nodes? I know Carpenter has unschedulable pods annotation that it adds to pods when it wants to add new nodes. So on that topic, do you have a proposal?
Yeah, my answer is not great, but so right now, this is one of the first entry points that why Kueue was created, was we used in an integration called provisioning request from the autoscaler. And this is what the Kueue workload does it before it was translating like a job into a set of pods and then requesting the autoscaling to trigger a provisioning request, which does create more nodes. That's at least kind of how Kueue does it, where you have basically you take a workload and it converts into a provisioning request, and that triggers the auto scaling to scale up. Because one of the issues, before that, you basically just have a bunch of pending pods, and then you hope that the auto scaler will create enough nodes to fit that. And that was one of the main reasons why Kueue, at least with the Google folks for Kueue, they really wanted the integration with the auto scaler. So it's like one of the first features they added. Now with workload aware scheduling, it's unfortunately quite messy now. Like that's the next step for somebody, not me, is the auto scaling community. It wants to now has to figure out like how to support all these APIs. And that's why there's an idea of like a scheduling library to kind of make it easier, because from the cluster auto scaler from from the Kubernetes side does have sort of it imports the Kubernetes scheduler, but I think I'm not involved here, so I know there's a lot of work that goes into that, and so now they're having to kind of figure out how to adapt these APIs. Carpenter, sorry, I forgot to mention on Monday at KubeCon, we did have an offsite at Google for a full day, kind of talking about all this work and laying out the plans, and auto scaling was like a big topic about how to bridge the gap between the cluster autoscaler and Carpenter, and how do we get everyone to kind of have like workload aware auto scaling. Unfortunately, I cannot say there has anything been implemented yet. That's one of the hopes of the library, is to kind of streamline this as quick as possible. But yeah, that's at least a long way of saying there is work ongoing there.
Thank you.
One little tiny thing that this slide reminds me of is that WG Batch, this group has always had a Slack channel called Batch WG, and it has led to massive amounts of confusion. It's been lovely. This group now is called the Batch Subproject, and I am in the works to like change it everywhere so that it's a little clearer that WD Batch is the Kubernetes level and Batch Subproject is the CNCF level. Maybe one day it will be slightly clearer. Victor.
Yeah, this is a more generic question. So just like the Gantt scheduler failure, is there any best practices, just like hardware-wise we put it the other way, problems can cause biggest problem, hardware problem. The reason is for agentic AI, which is basically based on the inference stack, the requirement for availability is higher, right? So when you, for example, if you create a transaction for the agent to purchase a plane ticket for you, it will first go to the website, try to find the ticket, then later on need to actually make the purchase by going to the bank to make the financial transaction. All of them has to be atomic. So there are solutions such as from this solution, which is the DBOS, which is in a way getting rid of operating system for all. So this way the transaction integrity is maintained throughout the whole atomic, it's no longer a transaction, it's a whole series transaction as one. So that's why how to making sure that when you schedule workload, not only can be rescheduled but also maintain integrity throughout. That's both a software problem and as well as hardware problem.
Yeah, I mean that's I think a very valid point. I don't know if I'm not too sure if that work is in scheduling scope right now, but generally there is a lot of concerns and ways to kind of make sure that we are smarter about hardware failures. It's kind of scattered though, because there's a lot of ways hardware can fail, and I guess what inferencing needs is very different from training. So from in my neck of the woods, what I see is a lot of like, the topology, like topology aware scheduling, at least making sure that you can, if a node fails, you can relocate the jobs to a different node. That's some of the work I've been seeing going on from Kueue and the job set side, or you can trigger a rescheduling of an individual job inside of a job set to kind of account for these failures. In terms of how do you guarantee that no failures happen, I don't know that one. And then disruption is more about if there is a preemption, or if the scheduler decides that something needs to be preempted, it will trigger a preemption of all the pods. In terms of disruption, I think that is something we're discussing, because there is also some other work going on in the Kubernetes community around like a proper disruption API to kind of make it more to like disruptions, make them more atomic. Because I think there's some issues we have with the drain and stuff, but it was an area that we talked about in the scheduling summit. But I think that everybody needs something very different. I'm thinking back to when I worked in multi-cluster and how every company has a different thing that they want to have solved. And I think with like node disruption is kind of a similar thing. And yeah, so thank you, Marlo. But yeah, I'm sorry, that's a long way of answering. I guess not answering your question that well. But there is a lot of interest in the community around hardware failures. I don't know if the original scope of this one is there. It might also be part of the device management. I know from the DRA community, there's a lot of interest in solving like device health.
Yeah, this is actually the discussion topic being discussed, Alex, in the OCP community, Open Compute. What is the problem to be and because at this point the problem is not well understood. So Kevin, yeah, if there's any I'll probably offline to see, is there any at least problems that has been identified as just cannot be solved, hard to solve, then yeah, and then that's probably not going to be a single solution from either Kubernetes or hardware or RMD, or it's probably a combination of some sort.
Yeah, I think some of it is, in the HPC community, they kind of took the approach that like failures will happen, so you just should have some kind of concept of checkpointing, especially if you're doing training over months. Like looking at all the papers on large scale training, most organizations are adding some kind of fault tolerance to their workloads because they can't afford to just retrain if your nodes are failing every couple weeks or even more than that. Like you kind of just have to accept those failures and figure out ways to get around that. But guaranteeing no failures, I think, is really hard. And I don't think anyone has really done that.
Yeah, it's not what. Yeah, it's not what we do either. Yeah, we expect failures for sure, hardware failures.
So Alex,
so-
for you, what do you, I guess from the Armada scheduling side, do you like, I guess, do you see this being useful?
I don't know. Like from the G research side, I wonder whether like the internal tools around submitting to Armada have calcified to the point where like people are just like it's fine, or whether
Yeah, that's a general problem with Kubernetes in general. Like, things you figure out something that works, and then you'll never touch it again. It's kind of the issue.
exactly. But then there are some other forces that might impact this, like if this eventually starts helping multi-node inferencing, for example, like we've done some work internally for multi-node inferencing, and completely ignored things like LLMD and other external work, that's probably to our detriment. But I have a feeling that this, maybe not just yet in 135 or 136, there's not much impact on multi-node inferencing, but it feels like it will tend that way.
Yeah, and I would say that right now one of our hopes is like we're designing the API, and why we're kind of, the talks and meeting people is trying to get the use cases up front, because I think we know we need gang scheduling in core Kubernetes for part of the motivation from, even though Kueue does it from the Google side, it doesn't really benefit a lot of people doing like multi-node serving, because they may not want to use Kueue. Like maybe they just want a job getting scheduled and they don't want to build in a full scheduler to do that. So like I think a lot of it is like use cases and seeing like if we missed anything. So, but I do know from where you are from the G research side, I do remember those days. So
I realized that we didn't get back to James ever. James, is there anything quick that you need to relay to us, or should we just hit this topic at the beginning of the next meeting?
Well, you guys can hear me, right?
Yeah.
Okay. So at the moment, we are particularly working on the white paper thing, figuring out and deciding that if we made a right choice on the particular sets of choices we have begun with. So it's all about right now documenting and figuring things out. But now very soon we will need to get our hands dirty with the infrastructure too. So we are waiting if CNCF could help us with the infra thing to make
Cool.
the AI wins ahead. Yeah. Would you like to
Yeah,
add, Philip?
yeah. I feel like for the documentation that I started off talking about the Git repo, that might be useful for this documentation too, like a place to chuck a whole bunch of the work that you've been doing that's visible and shared with everyone. So, um, and then yeah, I think Marlo is on the hunt for those resources for you too. Something we could talk to Boris about, Tommy. It might be something. I might get Boris back in a week or two, so in the next 2 weeks, for talk on OpenGris. I think Boris wanted to join us on, I guess that would be April 21st, to talk about OpenGris, which is this thing, OpenGris, which is, sort of a simple dispatcher, which is where everyone starts. And yeah, it's like that. So I gotta get something at the door, 1 sec. But we're at time anyway, so I'll just bid you adieu here. Thank you very much, Kevin. Super appreciate you coming and joining and sharing so much with us. That's really, really useful. And hope to see you in 2 weeks. Hopefully that's with Boris, and we can harangue him then for some AWS resources, maybe, James. So, yeah, thank you. Appreciate it.
Yeah.
Thank you.
Yeah.
Yes.
Bye.